Now, next topic, that is the concept of potential energy. So, first of all, we have to give the definition of potential energy. Okay. Now, the capacity to do work or energy possessed by the body due to its position in the given force field or its configuration, that is called potential energy of the body or system. Clear? Now here we will discuss two potential energies. One, that is gravitational potential energy, and second, that is elastic potential energy. Now gravitational potential energy, V as a function of H, that is given by the negative of the work done by the gravitational force in raising the object from the surface of the earth to height h. So we can write V at height h, the potential energy at height h, that is mgh. If we differentiate this one with respect to h, then we can write dV by dh, that is equal to mg. If we apply negative sign on both the side, then we can write minus dV by dh, that is equal to minus mg. But minus mg, that is equal to gravitational force. So here we can say this thing, the gravitational force F is equal to the negative of derivative of V with respect to h. Okay. Now see here, Fx, that is minus dV by dx. In general, we can write like this. Okay, x, that is the position. Take dx on left hand side. So f as a function of x into dx, that is minus dV. Now integrate this equation on both the side. So we can write integration xi to xf fx dx. Xi, that is the initial position, that is the lower limit. Xf, that is the final position at, and that is the upper limit. That is equal to minus integration Vi to Vf dV. Vi, that is the potential energy at initial position. Vf, that is the potential energy at final position. Clear? So see, let's write down one more step here. So minus integration dV. So here we can write integration dV, that is integration 1 dV. We can take 1 there. So we can write 1, that is V raised to 0. Now if we write this one as, that is equal to minus integration Vi to Vf V raised to 0 dV. Then this integration, that is equal to minus V. Negative sign is already there, keep it as it is. Integration V raised to 0 dV, that is V, and limits Vi to Vf. So substitute the limits, that is equal to minus. So V equal to Vf, the upper limit, then V equal to Vi, lower limit. Now if we implement this negative sign inside the bracket, then we can write Vi minus Vf. Clear? So here work done by variable force, that is the negative of the change in potential energy, we can say. Negative of the change in potential energy, because change, that is final minus initial. Now here we can observe this thing, the work done under the effect of the variable force, that depends only on the initial and final position in the given force field. It does not depend on the path through which the object or the system is moved from initial to final. Okay? So the work done by the force such as gravity depends on the initial and final position only. So this type of force in which the work done, that depends only on the initial and final position, but does not depend on the path through which it is moved, this type of force that is known as conservative force, and the force field that is known as conservative force field. Clear to all of you?